Okay, so today we're going to look at, we were looking at, if you remember, we've been looking at scatter plots, and then we talked about the other day about how to describe them. So remember we've always got to have our response and our EV, and then we had a scatter plot, say for example there, and we talked about the form. So we might say for this one it was linear, it's following a straight line pattern. We then talked about, we have to say the direction, which I'm going to say is positive. And then we talked about the strength, and we looked at finding the R value. So I'm going to have a guess this one that I just made up would have been strong. So I'm going to say approximately had an R value. I'm going to say just 0.8, okay? All right, so that's the R value, and that's what we did. We're now going to look at this number called the R squared value. So it simply is the R value squared. But what it's called, now it has a bit of a different name. It's called the coefficient of determination. So you need to be really careful. Lots of kids read the questions quick and aren't reading which one they're asking for, R or R squared. So what does the coefficient of determination tell us? It is the degree of which one variable can be predicted from another if it's a linear related variable. And so what that means is, so say over here in my example, I said that this was your weight, because remember, to have a scatter plot, you've got to have two numericals. So I'm going to say I was looking at height and weight. Okay, and say I said it says R was 0.8, okay? So if I square the R, it would be 0.64, okay? And then what we often do is we change the 0.64 to a percentage. So what do you think that would be as a percentage? Yeah, good. So we change that to 64%. So what it does, what the coefficient of determination, or R squared, tells us is that 64%, so 64% of the change in weight, so the weight that I see changing is due to the height changing. All right, so what I'm saying, so 64 of the change in weight is due to the changing in height. So we're seeing, as we're moving kids or people up in the height values, we're seeing 64 is affecting their weight in some way, okay? So then we would say, and that makes sense, and then maybe there's 36% of other factors influencing the changing. And would that make sense? You know, you could have genetically someone's bigger, you know, or whatever. So that's what the R squared, so when they say how it varies, often it's probably easier if you think of it, you can use the word changing, it's changing. So you often have to write a statement of what the R squared is and then use it to interpret in terms of the data. So what you need to do, and I've got it here in your notes, this is very important that you write out your statement with this wording. So here, with my example, I would be saying the coefficient of determination tells us that. Now, I would say 64%. So I've told you in brackets, you have to times your R squared value by 100. So I said tells us that 64% of the variation in the weight, because that's my RV, is explained by the variation in the height, because that's my EV. So can you understand, boys, I've highlighted the yellow because that's what you need to change for your scenarios. Is that clear? So you write exactly that, and you write what's your variables or whatever, or your R squared with the yellow. And if you do that, you're going to get your mark. There's no debating, you've written the right wording. So when we say 64%, that's pretty significant. But sometimes we give a rough thing. If you found out that the R squared, because your R might not be very strong, like you might not have a really strong relationship. So when we get an R squared value greater than 30%, we'll say that's significant. If it's lower, look, really, that's too low. There must be some other influence that's another thing that's associated with your variables, which is more of an influence, okay? So we just have to know if it's under that, it's not really, under 30, it's not really significant. Okay, so yeah, so here we've already done that example. All right, let's keep. Okay, so in the previous, so here they've told us and they've given you that little example, and I showed you how to do it with my template. So if you have a look, you had to change that, you had to change that, and you had to change that. So this was your response variable, this was your EV variable, and this was your R squared as a percentage. Okay, so you can see they've done that little thing. Okay, so this is R squared. So sometimes if you think of a number being squared, if we have 2 times 2, we get, which is 2 squared, isn't it? So I'm going to say 2 squared, that's 4. What about if I do negative 2 times negative 2? What's that? 4. So what happens if I have to do the square root of 4? Say I said, what's the square root of 4? When you go to do your answer, if you were going to do that, you don't really know whether it was minus or plus 2, unless I told you. Okay, so this is why when, you would have seen in some kids in the methods, often you see when they say find the square root, you have to put both answers because you don't really know which it was unless you have some information to say it. So sometimes, and we've got an example here, is we get given the R squared. So down here, they've said the R squared value was 0.5210. And what they want you to do is go back to the R value, and they want you, so the question here is to find the R. So the way you find R is you have to do the square root of the R squared value. So I'm going to do the square root of 0.5210. So if we do that, so when I did that, I get an R value. Now I'm still constantly writing it's either plus or minus. So it's going to be plus or minus 0.7218, okay? So, but I've been given a clue to know which one. Is it a positive R value or a negative? Why is it a negative? Yeah, good. So this graph, and you'll have to say this graph is showing me that the R value is a negative. And so we can then so then is I'm just going to abbreviate negative. So we know, therefore, the answer for the R value. Now, it's set to 4 decimal places, so I've done that correct. We know that is, after all that, I didn't even leave room for it to be negative, that it's negative, okay? So there's our answer. Okay, so let's do this exams question. It says the scatter plot below displays the resting pulse rate in beats per minute and the time spent exercising. So here we've got a scatter plot. It's an RV. Here's our EV. And it says the coefficient of determination. So what you should do when you read these is as soon as I see coefficient of determination, I put the letter R squared next to it so that I'm not stuffing up. And then it says the correlation that wants the R. So remember, R is going to be the square root, and it's going to be plus or minus 0.8339. So, and is it going to be positive or negative? Negative. Yeah, why? Yeah, good. So because the graph is negative, we're going to have a negative 0.913. So the answer is A. Just write this on the video. When you do the square root on your calculator, it always says a positive number, doesn't it? Yeah? So you have to yourself think about it. That's probably a fault in the calculator. It should tell us it's one or the other. But so you have to really think about it and be careful when you're finding that. All right, so with this one, I was just want to talk about, so if we had this scatter plot and it was life expectancy was our response and HDI was our EV. Okay, so we found out that the R squared was 0.875. Sorry. So we knew that 87.5 of the variation in life expectancy can be explained by the Human Development Index, HDI. All right? But sometimes they ask you what is not explained. Okay? So this is telling us, the R tells us what is explained. So the way to find what is not explained, I'm doing 100% minus the R squared as a percentage. So up in that example, I would have been doing 100% minus 87.5%. And this is how I get 12.5% is not explained. So this was from a previous exam, like this was a few years ago. And it was on last year's as well. They said what was not explained. So you had to know the thing. So you had to be really careful because that not is it's just a tiny little word, but it changes it, okay? So be careful. Did come up and the examiners talked about it. Okay, so here's just another one. So it says the average gold price in dollars per ounce is plotted each year over a period of 1980 to 2000. The least squares line is fitted. So what's happened is, right, and we're going to learn a little bit. We'll learn this next week. It will go a bit further. So we've got a gold price along here, which is our RV. And then we have the year. So this is like a time series, so an EV. So they are both numerical, and something's going on, and it looks like it's going to go like this, okay? Sorry. So you've got a scatter plot. Okay, so I knew it was negative because we're going to learn this a little bit later, but I can see that this is a negative because of the negative gradient, okay? So we'll learn a bit more, so don't stress too much, but we need to show you now. So because of this negative here, I know it's a negative graph, it's a negative relationship, and therefore when they ask me to find the R value, okay, so the R value I'm going to go is equal to the square, it's going to be plus or minus the square root of 5364. Now I'm going to say the answer is going to be a negative because of that negative in the equation. All right, so what's 0.5364? So it's negative 0.7324, okay? So it's D. So just maybe write a note here. This is negative. I'm just going to use my abbreviation for negative because the equation tells me. Okay, and you can put in there that negative 141.25 times year is what's telling me that it's a negative, this negative.